Introduced to revitalize regional railways' long-distance network, the Class 158 and their sister units, the Class 159s, would illustrate one of the finest multiple-unit designs in the UK upon its launch in the early 1990s, with comfortable interiors and high-speed performance that gave intercity levels of travel to some of Britain's more remote railway corridors. And to this day, many units continue to provide the backbone of many a vital operation in all corners of the country. The story of the Class 158 goes back to the early 1980s, where British Rail was increasingly confronted by the growing difficulties posed by its aging fleet of first-generation diesel multiple units, which have been constructed in large numbers during the 1950s and 60s, with these DMUs, designed and built to a variety of different and often incompatible specifications, having once revolutionized regional rail services across Britain. However, as they entered their third and fourth decades of operation, they were becoming progressively unreliable, increasingly uncomfortable for passengers, and financially burdensome to maintain, with many of these older units also being afflicted with serious structural and mechanical issues, while their interiors no longer met modern expectations for comfort. Furthermore, the presence of hazardous materials such as asbestos within many vehicles not only complicated routine maintenance and refurbishment, but also necessitated costly and complex removal procedures to meet evolving health and safety standards, and faced with these mounting operational and financial challenges, British Rail's planners and engineers concluded that a comprehensive renewal of the DMU fleet would ultimately prove more economical, efficient and sustainable than attempting to prolong the life of rolling stock that was clearly nearing the end of its practical service life. In response to these concerns, British Rail initiated studies into the development of a new generation of diesel multiple units, and from the outset, two distinct design approaches were pursued, with the first focusing on a lightweight rail bus concept whose principal aim was to reduce both procurement and operational costs to an absolute minimum, with these lightweight rail buses being primarily intended for use on lightly patronized rural branch lines where revenue was modest and any savings in costs would be highly advantageous. The second approach, however, sought to create a more substantial and capable DMU, one intended to serve regional and longer-distance cross-country routes where greater speed, comfort and capacity were required, with this more ambitious specification demanding considerable technological advancements and a marked improvement in passenger experience. The specification for this more capable DMU was particularly ambitious by the standards of the time, with British Rail setting requirements for a maximum operational speed of 90 miles per hour, acceleration characteristics comparable to contemporary electric multiple units, and the ability to provide through passenger access along the train's length, while in addition, the design was to incorporate pressure ventilation, compatibility for multiple working with existing electric multiple units, and the ability to maintain performance even when operating with a failed engine, thus enhancing operational resilience. These requirements reflected British Rail's broader strategic goal of offering passengers a level of comfort and reliability previously associated only with intercity services, but applied to regional routes which had traditionally been poorly served, thus resulting initially in the Class 210 diesel-electric multiple unit, but despite this being technologically impressive, the Class 210 soon revealed several significant shortcomings. The complex equipment needed to meet the high-performance requirements proved costly both to acquire and to maintain, while additionally, limited physical space available within the train's design made many components difficult to access for maintenance personnel, thereby increasing downtime and repair costs, while operational experience with the Class 210 demonstrated that, while technically feasible, the level of complexity involved rendered it unsuitable for widespread production and deployment across the network. These shortcomings prompted British Rail to reconsider its approach, leading to a strategic shift towards a more pragmatic and sustainable design philosophy, one that placed greater emphasis on reliability, maintainability, cost efficiency, and the use of established proven components, and by 1983, British Rail had revised its specification for the next generation of DMUs based on the lessons learned from the Class 210 trials. The maximum speed required was reduced from 90 miles an hour to 75 miles an hour, as operational analysis had demonstrated that higher top speeds offered negligible time savings on many of the intended routes, which were characterized by frequent station stops and closely spaced services, while power output was standardized to 7 horsepower per ton, which was deemed sufficient to deliver acceptable acceleration profiles while keeping costs and complexity in check, while requirements for compatibility with existing electric multiple units were abandoned, simplifying both design and operation. However, auto-coupling and auto-connecting features were retained to facilitate efficient coupling and uncoupling of units during service, while other key elements of the revised specification included good ride quality, a noise ceiling of 90 decibels at full speed, an operating range of up to 1,000 miles between refueling, and an extended interval between major overhauls of 5 years or 350,000 miles. More importantly, unlike many earlier DMU designs that used twin-engine arrangements per power car, the new design specified a single engine per vehicle, with sufficient cooling capacity and system redundancy to ensure continued service even in the event of a partial engine failure. While the design was also conceived to be modular, allowing for the flexible formation of 2 to 4 car train sets with varying configurations of passenger facilities, such as toilets and luggage compartments tailored to different service needs. Having formalized this revised business specification, British Rail issued it to manufacturers as a broad technical tender, inviting bids for the development and construction of prototype units, with British Rail Engineering Limited, or BREL, drawing upon its extensive experience, submitting a proposal based closely on the existing Class 455 electric multiple unit, utilizing the same basic body shell and running gear but adapted for diesel operation. Metro Camel, another established rolling stock manufacturer, submitted a competing bid which incorporated a lightweight aluminium structure that offered meaningful reductions in vehicle weight, with British Rail ultimately authorizing the construction of prototype units from both manufacturers, leading to the development of the BREL-built Class 150 and the Metro Camel-built Class 151. Between 1984 and 1985, these prototype units were introduced into trial service for extensive evaluation, with testing revealing that both designs met many of the essential criteria, but the Class 150 exhibited superior ride quality, reliable engine-out performance, and proved easier to maintain thanks to its less complex construction. And though the Class 151 demonstrated commendable performance, early concerns about structural flex and long-term durability contributed to its eventual rejection, and as a result, British Rail placed a production order for 50 Class 150 units, marking the first phase in the widespread replacement of first-generation DMUs. Even as the Class 150 units entered production, British Rail recognized that the needs of certain longer-distance regional and cross-country services would not be fully addressed by this design. And while the Class 150 offered considerable improvements over the first-generation DMUs, its interior configuration, with openable windows, vestibule doors, and 2x3 seating, was not considered sufficiently comfortable for journeys of greater length and duration. Many of these routes still relied on aging locomotive-hauled trains, which were costly to operate and suffered from poor timekeeping, and British Rail therefore sought to develop a more refined and capable derivative of the Sprinter family that could deliver intercity-style comfort and reliability on regional routes. To address these requirements, engineers explored modifications to the existing Class 150 design, with one of the key improvements involving the introduction of sealed windows and relocated end vestibule doors, which would significantly reduce internal noise levels while maintaining a more stable internal climate, with the lengthening of the vehicle bodies allowing for additional internal space, making it possible to replace the somewhat cramped 2x3 seating configuration with more spacious and comfortable 2x2 seating. Although these enhancements resulted in a modest increase in vehicle weight and a corresponding slight reduction in power-to-weight ratio, simulations and test data indicated that service performance would remain broadly unaffected, with journey times remaining competitive, while the modified units would also consume less fuel than traditional locomotive-hauled services, also generating lower maintenance costs. After careful consideration of these improvements, British Rail finalised the detailed design specification for what would become the Class 158 Express Sprinter, with British Rail Engineering Limited at Derby being awarded the contract to design and manufacture the new class, with the body shell being fabricated from lightweight aluminium alloy, contributing to improved acceleration, fuel economy and reduced track wear. Twin-plug passenger doors were fitted at each end of the saloon, offering better sealing and insulation against external noise and weather, while under the floor, each car was equipped with either Cummins NTA 855R1 or Perkins 2006 TWH turbocharged diesel engines, depending on the subclass, and these engines were coupled to Voith T211R 2-speed hydrokinetic transmissions and combined a GM190 final drives, delivering smooth, efficient traction across a range of speeds. Depending on engine specification, power output per car ranged from 350 to 400 horsepower, with the design allowing for a maximum service speed of 90 miles per hour, comfortably exceeding the capabilities of the first-generation DMUs they were replacing, while physically, each vehicle measured 76 feet and 2 inches in length, with a width of 8 foot 10 inches and an average weight of approximately 38 tons 10 hundredweight. The interior layouts were designed with passenger comfort as a priority, reflecting British Rail's desire to attract passengers back to regional services, with seating arranged as spacious 2x2 configuration, with both airline-style and table seating arrangements provided, and the units featured fully carpeted saloons, large panoramic windows that offered generous natural light and excellent views, and were the first British regional trains to offer air conditioning as standard. Additional passenger amenities included power-operated internal doors, modernized toilet facilities, including accessible toilets, and dedicated luggage storage areas, with provision also being made for refreshment trolley services, further enhancing the onboard experience for longer-distance travelers, with each unit being designed to operate for up to 1,600 miles between refueling stops and complete 13,500 miles between major servicing interventions. The initial two production units, numbered 158701 and 158702, were the first to emerge, but the early entry of the Class 158s into testing revealed a number of serious manufacturing and quality control issues, with BREL facing challenges in achieving the build quality required for such a sophisticated unit, particularly in regard to the complex wiring, new air conditioning systems, and the lightweight aluminium body shell, which was a notable departure from traditional steel construction. These difficulties contributed to significant delays in the delivery schedule, with units emerging from Derby often requiring rework and modifications to correct deficiencies identified during factory inspections and subsequent testing, with the first two completed units, while technically operational by late 1989, being subjected to an extended program of rigorous evaluation, which identified numerous teething problems that required rectification before passenger service could commence. After months of troubleshooting, system adjustment, and ongoing negotiations between BREL and British Rail's regional railway sector, the first Class 158 units were finally accepted into revenue service in September 1990, almost a full year behind the originally envisaged entry date, with the inaugural operator being ScotRail, who deployed these new trains initially on the important intercity corridor linking Edinburgh to Glasgow in order to replace Class 47s and Mark II coaches with DBSO push-pull cab control cars. Over time, as additional units were delivered and entered service, the operational reach of the Class 158 within Scotland expanded considerably, and services were extended northwards to include routes serving Aberdeen and Inverness, allowing ScotRail to withdraw large numbers of life-expired first-generation DMUs and locomotive-hauled services, with the Scottish allocation being composed of two-car units, with one vehicle in each set equipped with a modest first-class saloon to provide premium accommodation for longer journeys on these key regional corridors. As production gradually increased, attention soon turned southward to northern England, where the need to modernise cross-Pennine express services was particularly pressing, and on January 20, 1991, the first Class 158 units commenced operation on the Trans-Pennine route, specifically between Liverpool Lime Street and Manchester, though ongoing delays in delivery of new stock meant that in order to meet the operational requirements of a newly intensified timetable, 13 units originally intended for permanent deployment in Scotland were temporarily redirected to these services. This allowed British Rail to inaugurate the improved timetable without further delay. While recognising the heavy demands of these cross-country routes, British Rail Engineering Limited produced a batch of bespoke three-car Class 158 sets for dedicated use on Trans-Pennine services, with these sets, numbered 158798 to 158814, incorporating motorised centre vehicles, themselves numbered 58701 to 58717. Unlike their Scottish counterparts, these Trans-Pennine units were configured exclusively with standard class accommodation, prioritising seating capacity to cater for the high levels of demand on these busy routes connecting the northwest and Yorkshire with the northeast and beyond. And once the production difficulties had been largely overcome, the Class 158 fleet began to expand its presence across the wider British Rail regional railways network. New units were allocated to depots in Norwich and Cardiff, where they were swiftly introduced to handle semi-fast and longer-distance services across East Anglia, South Wales and the southwest of England, and the arrival of the Class 158s on these corridors marked a significant turning point, as the new trains displaced not only the outdated first-generation diesel multiple units, but also replaced a number of loco-hauled services that had long been the norm for regional express work. At the same time, regional transport authorities sought to benefit from the new generation of units, and the West Yorkshire Passenger Transport Executive, or WYPTE, responsible for coordinating rail services around Leeds, Bradford and the wider West Yorkshire conurbation, placed its own order for 10 Class 158 sets to supplement its fleet, with these units being constructed with slight internal modifications to suit local operating conditions, with seating capacities of either 70 or 72 passengers per car, and were delivered in WYPTE's own distinctive red and cream livery. Between 1989 and 1992, a total of 182 Class 158s were built by BREL Derby, with the completion of the West Yorkshire PTE order bringing the initial production run to a close by the end of 1992, though the design would not come to a stop with the 158s, as elsewhere on the British Rail and overseas networks, the general configuration of a fast but comfortable multiple unit could find additional applications. In the latter part of the 1980s, Network South East found itself facing mounting operational difficulties on its West of England routes, which connected London Waterloo with key destinations such as Salisbury, Yeovil Junction, Exeter St David's, and further into Devon and Cornwall, with these routes, though vital for both business and leisure travel, being characterised by a demanding operating environment that placed considerable strain on the rolling stock then in use. Services were primarily operated by aging Class 50 diesel-electric locomotives, all in formations of Mark II coaching stock, equipment originally designed for long-haul high-speed services rather than the frequent stopping patterns required on much of the West of England line, with the Class 50s, by this point already over 2 decades old, having become increasingly unreliable, with frequent mechanical failures that disrupted schedules on a route where punctuality was already fragile. Compounding the problem was that much of the track west of Salisbury consisted of long sections of single line, a legacy of earlier rationalisation during the Beeching era, meaning that even a minor breakdown could cascade into widespread delays, as there was little capacity for passing or recovering failed trains without significant disruption. And in light of these challenges, Network South East and British Rail's planners embarked on a comprehensive review of potential solutions to modernise the route and stabilise its service reliability. Among the various options considered was full electrification of the route, extending the existing third rail network beyond Worthing Junction, where the non-electrified West of England line diverged from the electrified Southampton mainline, with the electrification proposals coinciding with the potential to introduce a second batch of Class 442 Wessex Electrics units to run the Waterloo to Exeter service, though ultimately, the high capital investment required made this option difficult to justify, especially as government funding for the railways was under increasing pressure during the period. Another possibility was the introduction of shortened HST sets, which had already proved successful on other intercity routes, with the recent electrification of the East Coast Main Line to Edinburgh having seen a once thriving fleet of HST sets be replaced by Class 91 electrics and their Intercity 225 sets. But in the end, while HSTs would have offered excellent performance and comfort, their cost and operational complexity rendered them less attractive for the frequent stock pattern of the West of England services. Further proposals included the development of purpose-built diesel locomotives with modern coaching stock, or the creation of a dedicated diesel multiple unit derived from the emerging network family, specifically the Class 165 and 166 Thames turbo units, with the Class 171 Wessex turbo units being briefly mooted alongside a passenger version of the proposed Class 48 locomotive, but neither project advanced beyond the early conceptual stages. However, hope came when it was revealed that regional railways had inadvertently over-ordered Class 158 Express Sprinter units, resulting in a surplus of brand-new diesel multiple units that were yet to be allocated to specific services, and recognising both the opportunity and the suitability of these surplus units for its own requirements, Network South East negotiated to take delivery of 22 of these new trains. However, while these trains were mechanically suitable, the standard Class 158 configuration did not entirely meet the expectations of passengers accustomed to the greater comfort levels provided by locomotive-hauled stock on longer-distance intercity services. And to prepare the surplus Class 158 units for service on the demanding West of England route, Network South East arranged for these trains to undergo extensive modifications at Babcock Rail's facility at Rosyth Dockyard in Scotland. The conversion work involved a comprehensive program of alterations tailored to the specific operational needs of the route and its passengers, with first-class compartments being installed to meet the expectations of long-distance travellers, and retention toilets were fitted to comply with the environmental requirements associated with the train's intended operational territory. Additional internal adjustments were made to improve passenger comfort, including modifications to seating layouts, interior fittings, and other amenities appropriate for longer journeys, while technical adjustments were carried out to ensure that the units were fully compatible with the operational conditions of the West of England route. Once modified, the fleet was redesignated the Class 159, and the units numbered 159001 to 022. with each unit consisting of 3 cars arranged as 2 outer driving vehicles and a single intermediate motor vehicle located between them, with the driving motor cars carrying the numbers 52873 to 52894 and 57873 to 57894, while the intermediate motor vehicles were numbered from 58718 to 58739. To support the maintenance and daily servicing of this entirely new fleet, a dedicated depot was constructed at Salisbury, with this facility being purpose-built to handle the Class 159s and featured all the necessary equipment and infrastructure to manage the unit's technical needs, including their air conditioning systems, sophisticated braking equipment, and retention toilet facilities. The introduction of the Class 159s into traffic began in earnest during 1993, following the successful completion of the conversion program, with the arrival of the Class 159s bringing a significant improvement to reliability and performance, offering faster acceleration, greater availability, and a superior onboard environment, while the class also demonstrated considerable flexibility in formation to meet varying passenger demand across different times of day and sections of the route. On the busiest peak time services, particularly those between London Waterloo and Exeter St David's, multiple units would be coupled together to form lengthy trains of 6 or even 9 coaches, providing the necessary capacity for commuter and long-distance leisure travellers alike, while conversely, on quieter sections such as the Salisbury to Exeter corridor, a single 3-car unit would often suffice, and in Network South East publicity materials, the Class 159s were marketed as the Southwestern Turbo. At the same time, BREL also recognised a promising opportunity to export this advanced multiple-unit design to overseas markets, and in 1990, these export ambitions were realised when an agreement with the State Railway of Thailand, or SRT, was secured for the supply of a specially adapted version of the Class 158, tailored to meet the specific requirements of Thailand's rail network. Unlike the standard gauge tracks used throughout Britain, Thailand's railway system operates on meter gauge tracks, which necessitated significant modifications to the Class 158's design, and between 1990 and 1991, BREL constructed 20 carriages to fulfill the contract, with these vehicles being officially designated by SRT as the ASR class, and while these units were based on the same core design principles and mechanical architecture as the British Class 158, numerous technical adaptations were incorporated to ensure compatibility with Thailand's infrastructure, operating conditions and climatic environment. For instance, the narrower meter gauge running gear required extensive redesign of the bogies, braking systems and underframe equipment to ensure safe and stable operation on the tighter curves and lighter track work found across the Thai network. And while the ASR class bore a strong resemblance to their British counterparts, including the characteristic Regional Railways Express livery, several prominent external differences distinguished the ASR class from the original design. The units were fitted with robust high-capacity air conditioning systems, essential for ensuring passenger comfort in Thailand's tropical climate, where temperatures and humidity levels frequently reach extreme levels, with these climate control systems being powered by secondary diesel generator sets mounted within the vehicle to provide independent operation for the main propulsion engines. Additional modifications included altered door configurations to accommodate the low-height station platforms found across much of Thailand's network, while the driver's cab was configured for right-hand drive operation, and the front end was also substantially altered, with the characteristic gangway connections of the British Class 158 being omitted and replaced by a solid front with a central access door and side handrails, and the coupling system was replaced with knuckle couplers, which were more compatible with existing Thai railway equipment, supplemented by air and multiple unit control hoses mounted at drawbar height. Inside, the ASR class was fitted out with a configuration designed to suit long-distance express services common to Thailand's passenger operations, with the seating arrangements consisting of 4 abreast reclining seats, while each vehicle was powered by a Cummins NTA 855R diesel engine, delivering 285 horsepower, which was transmitted to the axles via Voith T211RZ hydrodynamic transmissions, and although the mechanical specification retained much of the proven Class 158 technology, operational speeds were limited to 120 km per hour, or approximately 75 miles per hour. Once delivery and commissioning were complete, the ASR class entered revenue service with the State Railway of Thailand on June 11, 1991, when train number 907 and 908 commenced services on the Bangkok to Chiang Mai route before returning to the capital, and over the following years, the ASR class established itself as a distinctive and highly visible component of Thailand's long-distance passenger operations. Back in Britain, British Rail's privatisation during the mid to late 1990s saw the Class 158 and 159 fleets pass largely intact to the newly created train operating companies, with their existing formations, allocations and operating patterns broadly preserved, with ScotRail inheriting a fleet of 46 Class 158s, which continue to operate throughout the Scottish regional and intercity networks, maintaining the roles for which they had originally been intended. These services included routes radiating from both Glasgow and Edinburgh, extending northwards to Aberdeen and Inverness, as well as serving longer distance journeys throughout the Highlands, with the main maintenance and stabling point for the Scottish fleet remaining at Haymarket Depot in Edinburgh, which provided the primary servicing for the fleet, while additional heavy maintenance and more specialised engineering tasks were undertaken at Inverness Depot, which supported operations on the more remote and challenging Highland routes. In Wales, the newly formed Wales and West franchise inherited a significant allocation of Class 158s from Regional Railways Wales, with these units being central to the operation of Wales and West's long-distance and semi-fast services, many of which carried the distinctive Alpha Line branding introduced by British Rail, with the Alpha Line services linking South Wales with North West England, North Wales, Cornwall and London Waterloo, providing important regional links over considerable distances. The maintenance and servicing of these units were managed at Cardiff Canton Depot, which became the primary base for the Class 158s in Wales, with the Cambrian line running through mid-Wales, increasingly becoming dependent on the Class 158 units during this period, with their combination of reliable mechanical performance, air conditioning and superior passenger facilities making them ideal for the extended and scenic journeys typical of the Cambrian coast services. Central Trains, which emerged from Regional Railway Central, took responsibility for a fleet of 36 Class 158 units, with these being deployed across a wide range of services within the Midlands, including routes between Birmingham, Nottingham, Derby, Leicester, Hereford and Shrewsbury, with the fleet originally split between Birmingham and Derby Etches Park depots for maintenance and stabling. As the franchise settled into its operations, a more comprehensive rebranding was introduced, and in 1999 Central Trains commenced a full repainting program, with the first unit to emerge from the paint shop in the new colours being 158797 in May 1999, but by the end of the decade, Central Trains faced growing issues with overcrowding on some of its longer distance services. To address the increasing demand, a restructuring program was introduced in 2000, which saw 8 two-car Class 158 units reformed into 3-car sets, classified as Class 158/9s, with this reformation involving reallocating driving trailers as centre cars to create higher capacity sets specifically for use on routes with heavier passenger loadings, particularly on interurban services linking the East and West Midlands. South West Trains, inheriting the entirety of the Class 159 fleet, maintained its operations with little alteration in the immediate post-privatisation period, with all Class 159s remaining based at the dedicated Salisbury depot and continued to perform their core duties on the West of England route, running services from London Waterloo through Salisbury and Yeovil to Exeter St David's, while also operating supplementary routes to Southampton. Virgin Cross Country acquired a small group of 5 Class 158 units, which had previously been operated by British Rail's InterCity business unit, and were deployed on cross-country services linking Manchester Airport and Liverpool with Scotland, as well as on routes between Swindon and Birmingham via Stroud, with the Virgin-operated 158s providing an important stopgap, while Virgin's longer-term plans to introduce new rolling stock, such as the Class 220 and 221 Voyagers, progressed towards delivery. Today, Class 158s and 159s continue to form the backbone of interregional services across the UK, working a mixture of some of the busiest and longest routes in the country, such as Liverpool to Norwich and Glasgow to Inverness, with subsequent refurbishments of the sets by ScotRail, Transport for Wales and First Great Western, having seen these units modified for the modern passenger market, while also ensuring their continued operation well into the future. However, the Class 158s have also faced replacement in many areas, with the bulk order of Class 170s in the early 2000s having rendered the class extinct from the West Midlands, while in Wales, the Class 197 Civity units are expected to take over from these units on a vast majority of their current diagrams during the mid-2020s, though elsewhere, Class 158s appear to maintain a secure footing in their current employ, with no viable replacements on the horizon. In the southwest, for instance, a recent influx of Class 165 and 166s, transferred from the London area, has increased the availability of Class 158s to work services to Plymouth and Penzance after years of their widespread absence during the late 2000s and into the 2010s, while for East Midlands Trains, Class 158s continue to form the backbone of the company's long-distance and regional services following the withdrawal of their Class 156 fleet, and Northern, who hold the largest fleet of 53 units, continue to employ them on all manner of workings. The Class 159s also remained the undisputed power of the West of England line out of London Waterloo, as supplemented by the arrival of 8 additional Class 158 units from First Transpennine Express, following their displacement by Class 185s in the mid-2000s, exchanging them for South West Trains' fleet of 9 Class 170s, with a fleet of 29 three-car sets now plying a high-intensity, high-capacity operation not only on the vital run to Salisbury and Exeter, but also to Bristol and occasionally Southampton. Therefore, by the third decade of the 21st century, and despite the advancing age of the Class 158 and 159 fleets, both classes continue to play a prominent role across Britain's regional and secondary mainline routes, and while newer fleets are steadily introduced to replace or supplement the sprinter units, their robust mechanical design, strong passenger comfort credentials, and the ability to be retrofitted with modern amenities allow them to remain operationally relevant well beyond their originally intended lifespan.